let's say we are comparing two projects, project 1 and project 2, and we are using both methods, IRR and NPV. If we are comparing using IRR, basically we will look at which one will have the higher IRR, and if we are using NPV, of course we will see which one have the higher NPV, right? Okay, decision for project comparison is not always consistent. What I mean by this is sometimes when you use IRR, it will suggest project 1, but if we are computing using NPV, it will suggest project 2. How does this come about? Let's see an illustration. This is a curve where the y-axis is the NPV and the x-axis is the chosen I, and the green curve is the project B and the blue curve is project A. So if you can see, there are situations where project B is better than project A, right? And here there are a range of yield, a range of I, where project A is better than project B. So where is IRR in this case? IRR is the point when NPV is 0. So NPV is 0 at the when the curve overlap the x-axis. So when the point go through the x-axis, that is the IRR. So the IRR for B is here, and the IRR for A is here. So if we are deciding using IRR, we will certainly choose A, because the IRR is higher. So when using IRR, we will certainly choose project A. But when we use NPV, it is dependent. It is dependent on what is the I chosen for project A and what is the I chosen for project B. That is appropriate for each project. So which one is the best method to compare investments, NPV or IRR? Actually, it is NPV. Why? It's because NPV is an appropriate measure of the value of that project, given the appropriate cost of capital or expected return from each project. So what happened to the position of the projects at the IRR of those projects is less of a concern, because it's not a true reflection of the actual cost of capital or expected return from that project. Okay, next question would be, is the yield rate unique? So as we see just now, IRR is is something that we need to solve. We need to solve for an equation of value, and then we derive the IRR, right? So when we are solving for the IRR, there could be three scenarios. There will be no solutions, no IRR can be found, or there will be one unique solution, as we see here, because the intersect is just at one point. And then there will be a situation when there will be more than one solution, because probably it will involve more complex polynomial where there will be multiple turning points. So because of the multiple turning points, the intersection on the x-axis will be on multiple points. So here there will be on 1, 2, and 3 points. So there will be 3 solutions for this project. However, the general rule is for any transaction which all outflow precede all inflow, or vice versa, the yield rate is well defined. Basically, it means that there will only be one unique solution. And this scenario is quite common, because it's quite common for a project that we will have to fork out an amount of money in the beginning, and then after that is paid, we will get a series of income after that. So due to that, it fulfills this condition, and so there will be one unique solution for those type of projects. Okay, we're done with the NPV and IRR. I will see you in the next video.